Hi guys. In today's lesson, we'd like to learn about a new type of logical statement. If you remember last week, we learned about the inverse and the converse and the conditional statements and the contrapositive. Today, we want to learn about what's called a biconditional statement. Our objective today, we're going to learn what a biconditional statement is and be able to form biconditionals. We'll also be able to write the two conditional statements that form a biconditional. The academic standard, well, it's from Logic and Proofs 3. State, use, and examine the validity of the converse, inverse, and contrapositive of conditional and biconditional statements. Here's the definition. A biconditional is a single true statement that combines a true conditional and its true converse. Notice the words true converse. We can write a biconditional by joining the two parts of each conditional with the phrase if and only if. Remember, the arrow implies P implies Q as the if-then statement. If P, then Q. The double arrow represents if and only if. P, if and only if, Q. Let's look at an example. If two angles are supplementary, then the sum of the measures of the two angles is 180 degrees. What is the converse of the conditional? Did you forget what a converse is? Remember, a converse is when you switch the hypothesis and the conclusion. If the sum of the measures of the two angles is 180 degrees, then the two angles are supplementary. Is the converse true? Yeah, it's true. So since the converse is true and the conditional was true, we can put them together in the form if and only if and get the following biconditional. Two angles are supplementary if and only if the sum of the measures of the two angles is 180 degrees. The second part. I want you to be able to take a biconditional and identify the two conditional statements, such as this. What are the two conditionals that form this biconditional? Two numbers are reciprocals if and only if their product is 1. Well, what's a reciprocal? Remember, a reciprocal is when you flip. We use these when we multiply fractions, or in this case, or most often dividing fractions. 2/3 and 3/2 are reciprocals. So we want to take this biconditional statement with the words if and only if and break it up into two conditional statements. So the first part, the two numbers are reciprocals, would become the hypothesis. And our two conditional statements would become if two numbers are reciprocals, then their product is 1. The other is the converse of that. If their product is 1, then two numbers are reciprocals. As we do this, remember, you can change verbiage around, you can change nouns to pronouns around to make grammatical sense. But that's what you're doing here. Remember, if and only if combines the hypothesis and the conclusion. A definition. A biconditional is definitely a definition because a good definition in geometry uses clearly understood terms. They should be commonly understood or clearly defined. A good definition is precise. They avoid words such as large, sort of, almost. And finally, a good definition is reversible. That means you can write a good definition as a true biconditional. Now, what we're going to talk about on the next slide is this. Is the following statement a good definition? Explain. If it's not, you have to provide a counterexample. A square is a figure with 4 right angles. Good definition or not? Think about it. A cat is an animal with whiskers. Opposite rays are two rays that share the same endpoint. The first, a square is a figure with 4 right angles. It's not a good definition. It's not reversible. A rectangle also has 4 right angles. Second example, a cat is an animal with whiskers. Not a good definition. There are other animals with whiskers. Me, for example, has whiskers. Third, opposite rays are two rays that share the same endpoint. That's true, but there are other rays that can share the same endpoint and they don't have to be opposite. Remember, opposite rays are two rays who form a line. So any angle that's not a straight angle would be a counterexample to that. That is your lesson today on biconditionals.